Okay, so we are recording, so this is going to be for A-Day, and we are going to take a step back because from the quizzes it looks like the scores are not as good as they should be, and I think we're still a little behind on the graphing. Like I was just telling these guys, we need to make sure that we're kind of going back to the basics here and going back to the foundation of these graphs. Okay, so I'm going to start kind of a little overview of the entire thing. So you guys here in class, definitely take some notes. You guys on the video, you should be taking notes in your daily notebook as well. Okay, so let's just kind of go over. Today we'll be talking about motion graph review. Come on. Again. I just brought that one over. David, you're the man. How's this thing work? There it goes. Okay. So, motion graph review. Okay, we're going to start from the basics again. Okay. There are three things that we're going to talk about, okay? That might be a little too much. Okay. Okay, we talked about position. Okay, what is position? It's really just the location of some object, okay? So if you want to describe the object's location, or you want to describe the object's position, you're going to say something like, the object is at 4 meters. Okay? Does it say how fast it's going or anything? No, it just tells us where it is. Okay? I think we're getting some of these things confused with one another. Okay? The position of the object. Okay, so let's talk about some graphs, some different position graphs. The way you really need to look at this is, obviously you got to make sure you understand what kind of graph you're looking at. Okay, so we got position down here, time down there. Okay. If I've got a position graph that looks like this, okay, I don't even want you to think about, okay, yeah, it's at rest. Think of it graphically. Think about it mathematically. If this position, maybe that's 4 right there, okay? And you're looking at this graph, and you're saying, as time is increasing this way, and position's increasing this way, right? That's how a graph works. My position is not changing. And if you say that in your head, my position's not changing, that makes me understand, hopefully, that it's at rest, right? Okay, so object at rest, which means it has a velocity of what? Of 0. It's not moving. Your speedometer says 0, right? Are we okay with this, right? Hopefully. I'm going to give you another example of a P graph here. Position graph. Okay, let's give it a little different scenario. Okay, now let's say my line is doing this. Okay. In physics, we want to know what the object is doing. Because in math, if you just said this is a linear positive line, which some of you did on the quiz, you're correct, but you're not correct in physics, because what is this object doing? You're trying to explain, you know, we're in physics, you're trying to explain the physical motion of the object, okay? So just saying this is a linear, positively increasing line is not correct. Okay, so, with this said, I've got a constant slope, yes, right? So that's maybe one observation we can have. It's a constant slope, meaning it has the same slope the whole time. And from that we can say it has a constant velocity. Okay, and what's happening to its position? Yeah, position is changing in positive direction. Okay, so some things I saw like on the quiz or whatever is, okay, is the position changing? Yes. Is my speed constant? No. Well, yeah, it is constant because I know that this is again, it's a position time graph, and if I've got a straight line, that means I have a constant speed. Okay? So if I zoom out here, and now I want to say, I'm going to create the velocity graph for these things. Okay, so let's say this is graph number 1 up here. This is graph number 2 here. Now I want to talk about velocity. Okay. How do we describe velocity? The best way, and I'm going to put velocity slash speed. For our purposes, it's the same thing. I think you guys are more familiar with speed. For our purposes, velocity and speed are basically the same. Okay. So how would we describe a speed or velocity? What is that telling us about the object? Huh?
The object is moving.
Yes, the object is moving. So if an object is moving, it has to have a speed or a velocity, right? But are we okay with just a simple definition like how fast something's moving? Okay, because that is as simple as it gets. Whoops. How fast an object is moving. I'll move this up here, hold on. How fast an object is moving. Okay, let's go over maybe another word that we throw around a lot. What does the word constant mean? Same, I heard. What does constant mean?
Staying the same.
Staying the same, right? Yeah. So it's staying the same, or yeah, unchanging. Can I have a constant velocity and be not moving?
Yeah.
How? I could have a constant velocity of 0, right? But could I also have a constant velocity of 6 miles per hour or meters per second? Yes. Okay. So let's talk about what these graphs. So graph number 1 from above. If now we talk about a velocity graph. Okay. So now this is VT. So our graph above was at rest, right? My object is not moving. So if again I'm at a stoplight, what's my velocity? Okay, so David, you're saying like this, is that right?
Yes, mostly because it's not moving.
Okay. So then, hold on, ask yourself, if I were to draw this right here, would there be any difference from this graph to the graph above? No. So it can't be the same. Your velocity graph cannot be the same as your position graph for any given scenario. So if I have a velocity of 0, I am at rest. Where's my line? It's down here, right? It's on the bottom. It is 0. Okay? 0 speed. Okay, now graph 2. Okay, I'm going to draw this one kind of like this because you'll see it like this sometimes, right? Where you have a positive, you have a negative quadrant. Right? So look at your number 2 graph, your number 2 position graph from above. Now my position is changing. If my position's changing, do I have a velocity? Do I have some sort of magnitude of velocity or number of velocity? Yeah. If my motion is changing, if I'm moving around this room, I have a speed. I have a velocity, right? And we said that this is a constant slope, the one from above, right? So if I have a constant slope, that means I have a constant velocity, and that correlates, since it's a positive slope, into the positive quadrant up here. This is a constant velocity. Okay, because I'm just going, it's the same scenario, it's just a different graph. Okay? Same scenario, different graph. Okay. Let's keep going here. Everybody go with that? Sorry. Yeah? Okay, I'm going to give you a graph kind of like I did on the quiz. It's going to have both positive and negative quadrants. Okay. No labels. Okay. No labels. Except for time. Time's always right here, right? You don't ever have to worry about that. That's always time. So as time progresses, what's going on with this scenario? Okay, I'm going to give you a scenario that looks like this. It's like I looked on the quiz. Okay, now, if this is a position graph, so it's a position, how is position changing? Whether it's a negative quadrant, positive quadrant. How would you describe the motion? Actually, let's just not do that. How would you describe this line mathematically? Huh? A change in direction? Is that mathematic? Okay, in math, they don't care about what the object is doing. All they care about is what this line looks like. Okay, I'm not asking about speed. I want to know, what's this line doing? Okay, it's going from negative to positive, which means, okay, so how could we describe a line in math? Okay, I could ask myself, is it linear? Is this line linear? Yes. How do you know? Yes, because really there is no curve, right? I mean, if I use a straight edge, it'd be a little bit better, but I did my best. What else could I ask myself? Okay, I could ask myself, what's the slope? What's the slope? How do I describe the slope of a line? There's two things I can do, right? The first thing, first thing I ask myself, is it negative or positive? You tell me. Is my line negative or positive? It is positive. Why? Because looking from left to right, okay, is going in a positive, so it's going up, it's lowest at the left and it gets higher at the right, correct? So it's a positive slope. You're going uphill if you're riding your bike from left to right on that line, you're going uphill, it's a positive slope, okay? Number 2. What else could I ask myself? Okay, really, how steep is it? Okay. We could calculate it. We could say rise over run, right? And we could actually get the steepness or the slope of it. But we don't have any numbers, so we can't really do that yet, right? Now, this was all math. Okay, all this is math. Now, how does this correlate into physics? Okay, now, because physics describes a real life scenario. Okay. So again, if this is a position graph, we're still talking about a p-graph. Okay, let's go up here. Linear. Okay, what does linear correlate to in a position graph? Yeah, people still want to say the word constant. That's okay. Okay, but it is constantly, right? It's constantly what? What's that? Okay, but we're talking about position, so try and talk about it in regards to its position. Its position is constantly what? Constantly increasing. Or you could also say it's constantly changing, right? Its position is changing at a constant rate. If it wasn't constant, it would be curved, right? Okay. So that's what linear means. Okay? Slope. We had 2 things we talked about slope. Okay, so 1, positive. It was a positive slope. Okay, this means what? What's the difference between a positive and a negative slope position line? Think about your moving man fet. Direction, right? So let's say positive, let's say the object is moving to the right. That's what positive means here, the slope, for the actual physics definition. And then our second piece, how steep is it? Okay. I would say this is a moderate slope. It's not steep. It's not not that steep, right? So what does that mean for its speed, Mr. Noller? If it were a V-graph, yes. So if it's moderately sloped, that means it has a pretty average speed, right? If it was steep, it would be fast. If it was not steep, it would be a little bit slower. Who do you need? Yasmin?
We're good.
Okay. So, are we okay with these things? All right. That's if it was a position graph. Now let's talk about if it was a velocity graph. Because is it the same? If this was changed to a V, right? Now we're talking about the speed. Is it gonna be the same type of motion? Same type of descriptors here? No, it won't, right? Okay, so let's go down below and figure out what that would be if it was velocity graph. Okay. Okay, so now let's talk about and see if it was a velocity graph. So kind of you'd be looking along there on your paper as well, because I'm going to be looking on my paper. Okay, if it's velocity, same thing. It's linear. Okay, so we're describing this in physics terms. Again, if it's linear now, okay, that still means it's constant, right? Because linear means constant, but what is now constantly changing? Constantly increasing speed or velocity. Is that the same as saying its position is constantly increasing positively? No. Okay? Because if my speed, or I'm sorry, if from the first one, if my speed is, I'm sorry, my position is constantly changing, right? That means I'm walking 1 meter every second, right? 1, 2, 3, 4, 5, 6, maybe a little bit quicker than a second, right? But now, if my speed is constantly increasing, now how am I going to have to walk? Okay, do I have to walk the same speed? No, I have to increase my speed. So, if my velocity is constantly increasing, I have to increase my speed the whole time, right? Now what's my position going to look like? Right? So these cannot be the same. Right? They can't be the same from graph to graph. Okay, so now the slope. Now what does our slope relate to? Well, if we said the slope of position graph is equal to our velocity, what do you think the slope of a velocity graph is going to equal? It's going to give us the amount that it's accelerating. It's going to give us the acceleration. Because you just told me that my speed was increasing, right? My speed was getting faster and faster and faster and faster. That's an acceleration, right? Speeding up. Okay, so positive does positive in this case necessarily mean it's moving to the right? No. Okay, so look at this. I'm going to redraw it kind of small here. This is my V graph, right? Okay, if I'm starting at a high negative velocity, okay, at maybe -5 or something like that, am I starting fast or slow? Okay, get it out of your head that negative means slow. Look at the number. Yeah, it's different direction, right? I'm just traveling to the left here. Okay, but as I'm traveling to the left, okay, remember, negative quadrant, positive quadrant. As I'm traveling to the left, what am I getting closer to here? What is this line in the middle? 0, which means what? If I have a velocity of 0 or speed of 0, what am I doing? I'm stopping. Yeah, and then what am I doing as I get up into the positive quadrant? Yeah, so this part right here is slowing down. This part up here, however, is what? It's going from 0 and it's increasing, right, up to, let's say that's +5. So what am I doing there? I'm speeding up. This was like what we saw on our quiz. This is the exact thing we saw on our quiz. So this thing actually turns around because it goes from the negative quadrant to the positive quadrant. And then if I were to get the slope of this, okay, and find how steep it is, okay, the steepness, what's the steepness going to tell me? If I do the rise over run of this, it's going to give me the value of my acceleration. My bad. value of my acceleration. All these things are connected. Okay, you guys are doing calculus right now. Do you know that? Anybody in calculus? So, position, going from position to velocity. Velocity is or the slope of the velocity. The slope of the position is a derivative of velocity. Okay. And as we move from velocity to acceleration, acceleration is the derivative of velocity. Okay, all these things are connected. So I'm going to fly through a couple things here. Alright, if you're maybe a memorization type, maybe this next part will help us. Okay, if you're still lost, just hang with me. We good with this on the board? Alright. We are going to start out simple. And I'm going to go through all three graphs. Okay. I'm going to give them all in this way that we do where we have the positive and negative. So there's my position, there's my velocity, there's my acceleration. So P graph, B graph, A graph. Okay? And I want you to think about going down this line, left to right. Okay? And then vice versa. Okay? Because if I know one, I know all of them. Okay? If I know one, I know all of them. Let's start really simple. If my position is doing this, my object is stationary. Actually, I'm not even going to talk about what the objects are doing. Okay? But if that line right here does not have a slope, that means my velocity is 0. Okay, and if my velocity is not changing, I cannot have any sort of acceleration. Boom. All three of those graphs are done. Okay, draw three small ones again. Still P, V, and A. Mr. Harris.
Sorry to interrupt.
Good.
We have a couple students need to come with me to lab A. Sorry if I mispronounced your name. Valeria.
What's the last name on that one? We have two.
Garcia Zamora.
Okay.
Jayla. Berkwan. We're in 203, right?
Yeah.
That's all. The rest are in 201.
Okay.
Just take your stuff, guys. You might not be back. We hope you are, but you might not.
Lab A.
Lab A. I'll just leave your passes over here. Talk to Mr. Coy if there's any work you need to get before you go.
Okay.
Thank you. Sorry to interrupt.
You're good. Alright, now we're going to go to the next level of position. So now I've got a linear position, right? Increasing. Again, if I'm going to my velocity, it's going to be flat, but positive, right? I have a velocity, it's constant. And then here, if my velocity is not changing, okay, it's constant, then this is 0. Okay? Keep going down now. 3 more. One sec, ladies. Now, the next progression we can have is this. Oops. Curve, right? If my position is changing like that, that means my speed, my velocity is increasing. And that means I have a constant acceleration. You can never, ever, ever ever, 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 ever have an acceleration that's not flat like this, okay? I mean, you can in real life, but for this class, I will not give you anything that is not going to be a flat acceleration, a constant acceleration, okay? Because then we really will be doing calculus. Now, let's say, let's do these again. 1, 2, 3. Just flying through some examples here. Move it up. Now I give you A. It's a negative acceleration. Negative acceleration. By only working backwards, and I don't even care if you know what this car is doing or this object is doing, what should our graphs be? Think about what the one just above it looks like. Okay, but now we've got a negative acceleration here. Ready for this? Everything's flipped. Keep going. One, two, three. Let's say I got, now I'm giving you velocity. Okay, that's your velocity line. You can get all the other two with just understanding that. Isis, what's my acceleration going to be for this? For this type of line right here? Remember, the slope correlates to this. Okay, so constant where? It's got to be specific. Because if I just did this, is there any different? Any difference in this? And this? No, it can't be the same. None of the graphs can be the same, remember that. What's the slope of the line that's like this? What's the slope of a flat line? 0, right? No acceleration. What's my position graph doing here? Okay, it's constant speed. How do I show a constant speed in the negative direction? Okay. Last one. Okay, this is how I would work through this one. Okay, starts steep. I know the steepness is going to relate to my velocity over here. I know that my velocity is changing because I have a curved line. It starts steep in the positive direction, which means it's going to start up here and it's starting fast. Maybe at, I don't know, 5 miles per hour, who knows. Okay, starting steep. And then it's getting less steep, less steep, less steep, less steep until it gets flat, which means I know when it's flat over here, that means that my object is stopped. So this thing is going to start fast, slow down, slow down, slow down, slow down, stop. Right? Now how would you describe the slope of this line? Because remember, the slope directly correlates to what my acceleration graph is. Positive slope, negative slope. Is it positive? Remember, think if you're a skier. Okay, if you're a skier and you're on this side of the mountain, right, and you're going to be going down, that's negative, right? If you were on like this side and you were going up, that's going to be positive. So left to right, you're reading always left to right, going from high to low means it's a negative acceleration. Constant. Remember, you can never, ever, 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 ever have what? You can never have a sloped acceleration. Good. Okay. Alright. Y'all need to come get this. Okay, come grab this from the top front table. We're going to go through that together. Today's kind of a together practice so that we can all be on the same page. You guys on the video should be getting the packet that says acceleration graphs, okay? Should look like this. Okay? Should look like this. Thanks, dude. Alright. We're going to work through this together, okay? I know I'm doing a lot of talking today, but I think it's quite needed right now. So, each of these graphs, okay, we've got our three graphs here, right? Boom, boom, boom. Same thing we just did, they're just in a little different orientation. Okay, they have the positive and negative axes here, and then each of these things gives us a scenario. This is going to teach us to really start understanding this vocabulary. Okay? A constant positive velocity and a positive position. Okay? That's telling me about its velocity and it's telling me about its position. Okay, if I have a constant positive velocity, maybe I'm going to start on my velocity graph. Okay? Okay, and if it's on a positive position, that means it's going to be in the positive quadrant. So how do I draw a constant positive velocity? Boom. Okay, remember, once I have one, now I have all of them. If I have a flat slope here, maybe it's a zero slope, okay, what should my acceleration be? 0. No slope. Okay, and if I'm traveling at a constant speed here, how's my position changing? It's constantly changing, right? Boom, done. Okay, so that's a simple one, right? It's going to get a little bit more difficult as we go through it. I hope everybody has pencils so that we can kind of go through this together. And I can kind of have you guys try it out and then you can check yourself. Okay, next one. It says, object has a constant negative velocity and a positive position. Okay, that positive position is telling me where it's starting. Okay, so it's starting at a positive position, so that's up there somewhere, right? And if I have a negative velocity, that means it's going to be in the negative area of my graph, and it's constant, unchanging velocity. What does this negative velocity correlate to for a position? Try and do that one. Talk about it with your partners. What should it look like? What does the negative in velocity mean? Remember, the velocity here is directly related to the slope of the position. So if I've got a negative velocity, that means I have a negative slope. So what's this thing doing? Yeah, you could go all the way through if you wanted, but it's linear, right? Okay, now, going from velocity to acceleration, if I have a line that doesn't have any slope, then my acceleration is 0. It's just going to take some practice, alright? Flip it over. It's going to start getting a little bit different here. Okay, object is now moving at a constant positive velocity, but now I'm starting at a negative position. A negative position. So that means I'm starting down here in the negative area. I have a constant positive velocity, which means I still have a constant positive velocity, which means a flat linear line in the positive quadrant, right? Positive, negative. Okay, but now my starting point's just down here. So if this is directly related to the slope, and I have a positive sloped position graph, linear, right? Linear increasing, positive. Okay? What's my acceleration? 0, because there's no slope for velocity, right? And if you think about this in realistic terms, Caleb, I hope you're done with this packet. You good on this?
Yeah.
You got 100% on your quiz?
Yeah.
You're 100% good with this. Want to come do the next one? 4. Come explain it to me. If I have a constant negative velocity, tell me where to start. So my velocity is going to start at 0? No. So maybe we should take our headphones off and listen. Okay, if I've got a constant negative velocity, please somebody tell me where I start. In the negative quadrant. And if it's constant, what's that line look like? Okay, and where's my position starting? Which means it's down here. This is going to be a little weird, so maybe we're going to start it right here. Alright. What's my acceleration? Is my speed changing? Nope. So that means I'm not speeding up or slowing down. Alright, so if I'm now going at a negative velocity, it's going to start in the negative, and it's going to keep getting even more negative. So it's going to be kind of short like that. Okay? Linear though, right? That's a positive position. This told us it's a negative position. Starting negative and getting even more negative. Okay? Flip it over. Alright, now we've got the A word. Constant positive acceleration, and it tells us we have a positive velocity. Oh my gosh, what's going on here? Let's start, okay, so it tells us where the acceleration is, right? So, a constant positive acceleration, that means it's going to start in the positive area, and I remember I never ever have an acceleration graph that is sloped. Okay, so now I'm going to kind of work backwards here. Okay, it says I have a positive velocity. That means it's going to have a positive slope, right? So I'm starting, let's maybe say I start from here, okay? And if I'm increasing speed, my velocity must be increasing as well, right? That line is showing me that as time is increasing, my velocity is also increasing, right? Now, how does that correlate to my position graph? Curved, right? Okay, we haven't done this one yet. Number 6 is going to be a tricky one here. Okay? Graphs of the object moving at a constant negative acceleration. Okay, I'm going to draw that. So negative, positive, I need to draw it down here. Negative acceleration, right? Okay. So if I have a positive velocity, that means it was up here, right, starting right there, right? And this is telling, the acceleration graph is telling me that this has a negative slope, because remember, slope is directly correlated to the one above it. Okay? So if I have a negative slope of my velocity, what's going on here? Okay? So if I finish at a velocity of 0, what's my car doing? It's coming to a stop, yeah. So, if I'm starting at a positive position here, okay, what is this going to look like? Okay, I'm traveling in a positive direction, which means I have to go in this direction, right? And then if I'm slowing down, my line is going to get less steep as I go forward in time, right? So it starts out pretty steep, and then it starts to slow down, and eventually stops, because that's flat, right? You okay over there? Okay, you guys on the video, keep going on this and try and finish the last 2 on your own. I'm going to go over these as these guys continue on. At this point, okay, if you leave today and you still do not know what you're doing, okay, you need to start coming to see me for extra help, because we're going to continue to move forward. So, good luck tomorrow. See you guys next time.